I try to put it in terms, and it's not, I'm not dumbing anything down. I want you to understand that. This is actually the best way to look at it. It's the people that can do math really well are the people that can put it in simple terms. Right? And it's not, it's just, that's what you do. What's he missing? Give it to him. What's he missing? Give it to him. Why technologize it all up? Why make it sound harder than it is? That's all there is to it. So why not just say it? So on the heels of that, let's go back, let's get into 6.6 again. The only difference between 6.6 and 6.4 is 6.6 are equations now. I can't cancel the denominator here, but if I have an equation, I can. So let's see. Let's try out. Let's start off nice. Okay. Now there are two different ways to do this problem. I like to do it the same way we did this. Or at least I like to teach it that way. Personally, I do things a lot differently. But to teach something, I like to teach this the same way I teach this, which is give everybody what they're missing. What are these two things missing?
5.
They each need a 5, right? Neither one has a 5. They both have an x plus 5. So he needs a 5. And she needs a 5. Why not?
Yes.
Now what's the guy in the middle?
X plus 5.
Good, exactly, right? X plus 5. So that's pretty easy to tell who's missing what, give it to them, right? Don't give it to them if they're not missing it. I always get people that give stuff to things that, they multiply this by x plus 5. It already has an x plus 5. Why would you do that? Don't give it what it has already. Only give it what it needs. Now here's the neat thing about equations though. Only equations because you have two sides to balance yourself out. What can you do in an equation that you can't do here?
Things to both sides.
I can kill the freaking denominators, right? If I multiply both sides by 5x plus 5, doesn't that cancel?
Yes.
So what's left alive then?
10.
10 equals
2x plus 5.
2x plus 10
10, yeah.
minus.
5x.
Now that's one step away from chapter 2.
You can only do that because of the equal sign?
Exactly. You can only cancel things if you have sides to balance you out.
Okay.
I have fundamentally changed this number. But it's okay because I did the same thing to the other side, so they're still equal to each other. The equation is still true. And now it's nice. Right? What do the 10s do? Yeah, they cancel. So you get 0 equals 2x minus 5x is.
Minus 3x.
Now for some reason people get a little freaked out here. This number doesn't tell you what to do. This number tells you what to do. How do you get the x by itself? Don't say add. Good. Divide by
0.
Negative 3.
negative 3.
X
So
is
that
still
cancels,
0.
right? So x equals
0.
0 over minus 3.
which is 0.
Yes.
Right? So I always get somebody tell me that's undefined because they're looking at the 0. You can divide by negative 3. There's nothing wrong with that. How you doing? What could x not be from the very beginning? X can't be negative 5. Did we get negative 5?
No.
So we're good. So at the end, you got to make sure the answers you get don't make the bottom freak out. If they do, cross them out. If they don't, good. Leave them there. All right, let's try another one. Here, you guys try this one here. I'm talking too much. Just wonder if anybody's thinking in their head, you always talk too much. 41.
6.
6, yes. So break the problem up into steps, right? You have a definite step 1 here.
Oh,
Was it when I
okay.
signed?
I did it.
Okay, okay.
Professor, what you did was you multiplied by 5 extra 5 steps that was on the bottom,
Exactly.
and then that
It's
canceled
really nice.
out.
Once you get them all the same, they basically all cancel, because you multiply by whatever that is.
Okay,
So your next step after giving everybody what they're missing is you get a nice chapter 2 equation.
okay.
No denominators.
So you just multiply that, so
Exactly.
go away.
I sort of catch up with you guys. And notice how, I mean, that wasn't hard, but when they get hard, look at the other pieces of the problem. They are probably a piece of what the hard piece is, right? You can do that shortcut I showed you earlier, or you can get practice in factoring if you don't like the shortcuts. Either way, it's great.
Do you need everything what they're missing, everybody what they're missing?
Yeah, so what's he missing?
X plus 3.
X plus 3.
Yeah, he's missing an x plus 3. Of course, the other dude's missing a
X minus 3.
x minus 3. Since it's an equation, I can now
Cancel.
multiply everybody. That's a weird ass.
Okay.
By the dot, that cancels there.
Oh, X plus 3 and X minus 3.
I can do that because it's an equation. Again, whenever you guys start to notice, I don't like denominators, I'm going to kill them everywhere. Wow. You can't. I'm sorry, Dr. Eagle. So what happens up here? You get
2x plus 6 plus x equal 2x
X
minus
minus
3.
12.
minus 12, again,
Oh, shit.
right? That's easy to do too, to forget to take that through. And now, like I said, chapter 2, section 2.1, if I remember correctly.
Combine by 12.
Yeah, so 3x plus 6, 4x plus 12, subtract, add, get 18 is x. So what you guys got?
Yeah.
And what could x not be?
Negative
Negative 3 or 3, did we get either of those? No, so we're good. If I got 3, I cross it out. No solution then, right? If I got 3, it freaks it out, no solution.
Plus 12.
We have to write x can be 3.
No, you just can cross it out and say no solution. But that's not one of the ones that freaks the bottom out. It's fine. Okay, how do you feel about that? I mean, section 6.4, if you get it, section 6.6 is like one extra step. It's the same idea. You just kill the denominators and then you get an easy equation to solve. Let's see. We're actually going to get into, you're going to love this, I know. You're gonna love stuff. We're going to get into chapter 7.
Okay.
Some brand new stuff. Let me start by asking you, remind me what we do here.
Multiply.
Exactly, right? Multiply.
Yeah.
Biggest mistake is I see people say 2 to the 10th. You guys aren't gonna do that, because you know you multiply it, so you get 3 to the...
27.
Now, I can put whatever the hell I want to, and I've done that before, like the bonus problems, right? Couldn't I put it 3 to the A to the B?
Yes.
Sounds like
A,
a rat.
I know, that's exactly what I was thinking. It's 3 to the A to the B. So what would that be? 3 to the AB,
Yeah.
right? So it really does not matter what I put up there, the rule doesn't change. Like I always say, rules can't change. So what the hell happens here then?
What is that?
It's trying to be a 3.
Okay.
It's a bunch of 3s, and why I picked 3, it's my worst number, I don't know.
3.
Because what happens? The same thing happens, right? 3 to the 3rd times 1/3, right?
Yeah.
What's 3 times 1/3?
3.
1.
And what's 3 to the 1st power?
3.
Interesting. So it does exactly what you would think it would do. A fractional power, it should cut this power down, right? All right, nothing too amazing there, really. What about 2 to the 4th? Get it in there, Jeff. To the 1/4. Not surprisingly, that would just be,
Also 2.
that would be 2, right? 4 times 1/4 is 1. Okay. You're all like, okay, Jeff, it's amazing. Remind me, what's the cube root of 27?
3.
Why?
3.
3 times 3 times 3 is 27, so you basically cut that in thirds, don't you? Sort of like this cut that in thirds, didn't it?
Yeah.
So the cube root of 27 is 3. But isn't 27 3 cubed? So doesn't a cube root, I really want to make this connection, this is the first time I'm trying to explain it like this, isn't a cube root the same damn thing as a 1/3 power? Because what does a cube root do? Cuts it in thirds. What the 1/3 power do? Cuts it in freaking thirds. So fractional powers, it sounds like a note whenever I slow down like that. Fractional powers are basically roots, also known as radicals. Square root, cube root, 4th root, right? So 1/4 power is the same thing as a what root? 4th root. Because the 4th root would cut it into 4 pieces, right? So another way to write square root of 9 is 9 to the 1/2. Square root, right? Not a cube. Because what does the square root do to 9? It cuts it in half, doesn't it?
3.
Yeah, what is the square root of 9?
3.
3. What is 9? Isn't it 3 squared? And what's 3 squared to the 1/2?
Yeah.
So this cancels, so you get 3? All right, so let me bring this back, make it a little more formal. Some of you guys look really excited about this. And again, I know a lot of what we do is repetitive from what you've done before, but so maybe some of you guys know this really well already, which is awesome. So if I have a number, let me do this a little more formal. If I have like an nth root of something, it's the same thing as that, so the 1 over n power. Right? So how would I do like, for example, the 5th root of a10? Wouldn't that be a10 to the 1/5 power?
Okay.
Because what's the 5th root do to something? Cuts it into 5 pieces, 1/5 of it.
So it'd be
And what's 10 times 1 over 5?
Yeah.
So we got a squared. Look at the shortcut. 5 goes into 10 twice. Right? Okay. So all the old properties, now that we got a kind of a feel for this, all the old properties still hold. You're just going to have to add fractions when you're multiplying things with fractional powers. Right? What about if it's not got a 1 on the top? What if it's like 8 to the 2/3 power? You could write that like this. Let me see if you guys agree with me. Isn't this the same thing?
Yeah, that's 2 times
Yeah.
Isn't it? Because 1/3 times 2 is still 2/3. I can break it up.
Yeah.
As long as I raise 8, as long as I square it, and 1/3 power it, I don't care which order I do it in. Right? But why is this nice? What root would this be? The what root of 8?
Cube.
Cube root of 8.
2.
To the 2nd power.